Guys, welcome to Mix Online Tutorials. In this episode, we'll be discussing on stresses and strain in bars of varying sections. Welcome back. In the last lesson, we discussed on the procedure of obtaining stresses and strain in bars of uniform cross-sectional area. So now, but in this lesson, we'll be discussing on the varying sections, because most of the times the sections we encounter are not always uniform. Some of them are varied in their section wise. So now we'll have to find the stresses and strain of these sections. So we'll be discussing on the bars of varying section, the types of bars of varying section. The first one we have is we have the bars of different section. The second one we have is bars of uniformly tapering section, and the third one is bars of composite section. But for this video, we'll be studying first on the bar of different section. While on the subsequent videos, we'll be studying on the composite and the tapering section. So now, to study these bars of different section, let us use an example to look more into that. Let us say we have a diagram here, or we have let's assume the area here is equal to 50 millimeter squared, and the length from here to here is equal to 90 millimeter, and the force, tensile force, is equal to 160 kilonewton, and the force also. If you remember this from the last video, we said if the force is going this way and in opposite direction, it's a tensile force. So the area here is equal to 100 millimeter squared, and the distance from here, from this end to this end, equals to 120 millimeter. So our what we are expected to do is to determine the total elongation of this component. That means we have to get the elongation of this component and elongation of this component. That's what I'm talking about. So you get this there and then get this, and sum it up together. So we have our tensile load. To be 160 kilonewton. Converting that to newton, we have 160 times 10 to the power 3 newton. So we also have length of section 1. We have length of section 1, which is equal to 90 millimeter, and length of section 2, which is equal to 120 millimeter. So we also have area of section 1, which is equal to 50 millimeter squared. So camera is not on it. So we have the area of section 2 to be 100 millimeter squared. This is a millimeter. And we have our E to be 200 gigapascal. And I said earlier on that you can convert this to kilonewton per millimeter square, or newton per millimeter square. But in this case, we'll be converting it to newton per millimeter squared. This is newton per millimeter squared. So so what we are expected to look for is the elongation. The elongation, which is equal to dl. So let us solve that here. So we say our elongation is equal to PL1 over EA1. Remember this formula. So now we will get for the first one. Let me put for the first one. Let me put the subscript 1 there. This is for the first section. Then we'll get the one for the for the second section. Or we can just sum it up. We can just sum it up to be equal to P over E. Since this is for L1, just substitute. We have L1 over A1 plus we have L2 over A2, making work more easier. This is equal to our P, which is 160 times 10 to the power 3, over our E, which is 200 times 10 to the power 3, from bracket L1, which is equal to 90 over 50 plus L2, which is what? 120 over 100. Now solving that should give you 2.4 what? Millimeter. Now that is that for your what? Your elongation. Now we'll be solving one more example to buttress more of this point so that you will understand it more. As I said earlier on, when we talk about uniform and varying sections, you have to get the elongation for one part, elongation for the other part, and then just sum it up together. So let us solve another example. So now the example we're going to be solving, now I said a circular steel rod of different section is. So let me draw the section so you can see that. Now this is the circular steel rod. Not much circular, right? Yeah. So now that is the first one. Now we have another part. I'd like you to pay attention because the one we're about to study now, if you don't understand the first one, you might not get it properly. So we have 70 millimeter diameter. So this is diameter, because this is a rod, as I said earlier, then circular rod, millimeter diameter. And then for this part, for this whole part, we have it to be 30 millimeter diameter. Now there's a force acting down, which is 25 kilowatts Newton, and the length, this is 1 meter. Length, this is 2 meter. Length, this is 1 meter. And we say this is A, B, C, and what? D. So now what we are being asked to do now is to calculate the maximum stress induced in this rod and its deformation. So we are going to be looking for what? We're looking for stress, and we're looking for what? Deformation. So now if you look at this, now there is a force here. So this is a tensile. There's a force also, which is 25 kilowatts. Newton. Also force taking it. So there's no, this is a, let me draw it accordingly. There's a force here. If you see this, you should be able to remember that we're going to be using principle of what? God bless you, you got it right. We're going to be using the principle of superposition. Remember, we've gotten the force 25, we've gotten the force 50, we've gotten the force 100, which is acting down, but we don't have the force here. I wanted to write 25 here, but I remember I then saw that it is not that way. There are some other internal forces. We don't know the force here, but we are going to get that force. So now, what we need to, let me split this. Now, this is our solution. Can you see that well? So now we need to get our what? Our area. Let us start by what? Getting our area. Now the first part, AB. Let us get our first part, AB. Now our first part, AB, will be equal to, now the area of, let me call it section 1, will be equal to pi over 4, open bracket, d square. Remember, from this pi r square, substituting value, because what we have now is our diameter. So we say pi over 4, okay, diameter 70 squared millimeter. That will give us 3848.5 millimeter square. We've gotten our area for the second one. Now our area for the second one, I will pi over 4 bracket d2 squared. So it should be inside, which will give us 50 all squared will be equal to 1963.5 millimeter squared. Now for the area 3. Now if you look at this section A, section 3, this is a space, so this is a free space here. So we know the area for this one, which is 50, and we also know that the area here, that the diameter for this and for this is 30, but we don't know the middle one, because what we want to get is all of this area. So we're meant to understand that there is a 30 that this is equal to what? 30 diameter. But we want to get also the middle part. We want to get this part and what? This part. Do you understand what I'm saying? Now this is the 30. So we want to get this part and what? This part. So we're going to be minusing 50 from what? 30 to get only this part and what? This part, because this is there's a free space there. Now to get that, we'll be having pi over 4 open bracket. This is going to be d2 minus what? D3 all raised to power. So this is squared. This will give us 50 squared minus 30 squared, which will give us 1256.6 millimeter square. So now we've gotten our area for each of them. Now let us get the forces on each of the members. We're going to be using superposition theory now to get the force. Now let us get our forces, because of that what we used to get our stress. Remember, our stress is force over what? Area. So we're just solving in accordance to get our force, to get our area. Now we're getting our forces of all individual section. Now let us start from AB. Let's start from section AB. Now this is the first we have for section AB. Now this is the 100 kilonewton going down. 100 what? Kilonewton going down. This is what? 50 kilonewton coming up. 50 kilonewton coming up. And this is what? 25 kilonewton. As I said earlier on, they will be treated as one entity. I said that in the previous video, and I made some other comment too. I would like you to also go back and visit that to be more clear when you proceed, when you approach on, to avoid confusion. Remember, we don't know any force here, because if you see the diagram, there's no force that was given us here or here. But we know that anything we have here will be counterbalanced by this one up there. So we have 100. Now this one is, if we look at it this side, we see that this one is going to the left, this one is coming to the what? Positive. This one is going to the left. So it will now be minus 100 plus 50, which is going to be what? Minus 50. Now minus 50 now minus 25 will give us minus what? 75. So we know our 75 will be coming here, and also 75 also will counterbalance it. So this is a tensile what? A tensile force. We've gotten for section EB. Now we need to get our section what? We need to get section BC also. So now we will take this part. Now remember, now we've known that. Remember, we've known our section AB. We've known the force to be what? 75. So let us get our section what? BC. So now we know our 75 to be coming here. Let me clean this. We know 75 to be up here, and we also know our 100 to come down. We also know our 25 to come down. We also know our 50 to come up. If you remember this, 50, 75, 75, then 25. If we do the mass here, we should be amounting. This is to the positive, this is to the negative. So we should be having, it should be minus 20 what? 5. So there's no minus there. And this one, so this is a compressive force. So this is negative. So when you're adding, or when you're getting your answer, you need to minus that. So that is for section what? BC. This is for section EB. And let me use this side to get our section what? CD. Now for your section what? CD. Remember, we'll not take them now as one entity. We'll no longer do that stuff. They will take them as one entity now. So now we have our 75 up. Now we have our 50 up also. And we have our 100 taking it down. If you remember, now this is the 75 having. So we have this, so we have this, we have this, and we have that. So that is how that came about. This is 100. Now for the down part, we have what? 25. So now if you solve that right, it should be amount to something like this. This should be 25. Should be what? 25. This is a tensile force. So we've gotten the forces in all of the section now. You see, it is quite easy. Just dedicate some time to solve this. So now we've now known the force. So now we can now solve to get our stress. Now stress and the first one will be what? PAB, that is the force in AB over what? E1. So now the force in AB was 75 times 10 to the power 3 over 3848.5. That should give us 19.49 Newton per millimeter squared. That is for the forcing. Now the forcing, the stress, it will be PBC over E2. Let me write it down so that, oh no, let me clean this. Is equal to PBC over E2, which gives us 25 times 10 to the power 3 over 19, which gives us 127.3 Newton per millimeter squared. Now to get your stress 3, we have 25 times 10 to the power 3 over 1256.6, which gives us 1.98 Newton per millimeter squared. If you are lost, I suggest you go back and clear your doubt. So now we have stress 1, stress 2, and stress 3. So what we need to get now is to what? To get our elongation. But our question is to get what? Our maximum stress. So which of the stress here is largest? Is it stress 1? So 19.49. Is it stress 2, which is 12.73, or stress 3, which is 19.89? So the stress 3 is our maximum stress. Now to get our deformation, I'll clean. Now let me clean the area part. Now to get our deformation, remember we've gotten. Now let's get. Now our change in L, which is the total deformation, is going to be amount to change in L1 minus change in L2. I hope you know the reason why there's a minus there, plus change in what? L3. So let us get all our changes, and we know our changing. So now if you look at this, we have our change in L1 minus change in L2 plus our change in L3. Now you have to get your change in L1, your change in L2, and your change in L3. I'll leave you to do that on your own. Let us see if. So I'll just be giving you just 30 seconds to do that, or 1 minute. You can pause the video and try that. So if your calculations was right, your change L1 should give you 0.097 millimeter, or and your change in L2 should give you 0.127 millimeter, and your change in L3 should give you 0.09 millimeter. So now when you add it together, when you add everything, your change in L2 should be 0.069 millimeter. I'll be dropping a comprehension for you to test your knowledge of this, so that you also have a strong footing when solving questions like this. Bye bye.